One tiny glitch happens online, and suddenly everything just grinds to a halt.
Oh, absolutely. Like a payment fails or something hiccups somewhere.
Yeah, and your whole task, maybe online shopping or banking, just falls apart. It really shows how interconnected these modern systems are.
Yeah.
And maybe fragile.
Definitely fragile if not tested properly. And that really brings us to our topic today, end-to-end testing. It's basically the strategy to make sure all those pieces do work together.
Exactly. So we've got some material here we're going to explore, and the mission for this deep dive is pretty clear. Figure out what end-to-end testing actually is, why it's so critical now, and how it works in practice. We're mainly drawing from an article that lays it all out.
Sounds good. So let's kick things off. What are we really talking about when we say end-to-end testing?
Okay, so fundamentally, it's testing the entire software application. Like from the moment a user starts doing something, right through to the final result.
But it's not just the app in a bubble, right? That's key.
No, exactly. That's the crucial part. It specifically looks at how the software integrates with all the external things it depends on.
Other systems, databases, different interfaces, all that stuff.
Right. And, maintaining those test environments, keeping them stable with all those external parts, that's a huge challenge teams face. One change somewhere else can just break a whole bunch of tests.
Yeah, constant updates needed there.
So the focus is really on those connections. Do they communicate properly? Does the data stay correct as it moves between them? The article really stresses checking dependencies, data integrity, communication pathways.
It's like making sure every section of the orchestra is not just playing their notes right, but playing together in time.
Perfect analogy. And the goal is, well, it's about realism. Trying to genuinely simulate a complete user journey in an environment that's as close to the live production setup as possible.
Using production-like data, production-like configurations.
Exactly. It's more than just clicking buttons on one screen. It's the whole flow.
Simulating how someone actually achieves a goal using the system.
It's the final dress rehearsal, really. And interestingly, the source mentioned another name for it, chain testing.
That paints a good picture, doesn't it? Those interconnected links.
It does. And its place in the whole testing process is important, too. It comes after other types of testing, right?
Usually, yeah. After functional testing, where you check individual features, and after system testing, which looks at the integrated software, but maybe not fully exercising all those external connections.
So it's that big final check. Does everything, including the external bits, work together to deliver what the user needs?
Mm-hmm.
And the article also mentioned it covers things beyond just direct user clicks, like batch jobs or data processing that happens behind the scenes between systems.
Right, the upstream and downstream flows.
Yeah.
That end-to-end name really fits when you think about tracing data all the way through.
Totally. So thinking back to that initial idea of system failures, this really highlights the why, doesn't it? Why should you, listening now, care about this?
Well, fundamentally, it's about making sure the whole system actually works as intended.
Yeah, the article says it verifies the complete system flow. It gives you much more confidence because you're seeing everything interact realistically.
So that nightmare scenario, one server glitch, takes down everything. That's exactly what good end-to-end testing tries to catch.
Precisely. And you uncover problems you'd just miss otherwise.
Yeah.
Right. Things that look fine in isolation, but break when they interact.
Exactly. That's where it really earns its keep. It finds those integration bugs.
And it increases your test coverage. You're not just testing your app, but how it plays with others.
Mm-hmm.
And the article really drives home this risk if any part of that interconnected chain fails.
The whole thing can potentially collapse.
Yeah.
Yeah.
So end-to-end testing is that safety net.
Okay, so it's vital, but how is it actually done? What are the steps?
Right, the process. The article lays out some key activities. First up, really study the requirements for the end-to-end tests. What flows are you actually trying to validate?
Makes sense. You need to know the journeys you're testing, start to finish.
Then you've got to set up the test environment. And this isn't trivial. It means replicating that whole production-like setup we talked about.
Yeah.
Hardware, software, everything.
Including those external systems, third-party services, databases, the works.
Yep. After that, it's about describing everything, mapping it out. Which systems are involved, what processes happen in each one.
Getting a clear picture of the whole landscape.
Then defining roles and responsibilities for all those systems. Who owns what piece?
Which is important for tracking down issues later, I imagine.
Definitely. Then deciding on the testing methodology. How are you actually going to conduct the tests? What are the standards?
Got to be consistent, especially with something this complex.
For sure. And then the core part. tracking those requirements, and designing the actual test cases.
Right. And finally, and this is crucial, defining the input data and what you expect to see as output from each system along the way.
Knowing what good looks like at every step. Okay, this sounds involved, especially with lots of systems. Are there tools to help?
Yeah, absolutely. The article specifically mentions one called testRigor as a leader in this space.
testRigor, okay, what's special about it?
Well, one of the big claims is no-code test creation. You can apparently write tests in plain English.
Oh, interesting. That could lower the barrier quite a bit.
Potentially, yeah. And they talk about covering a lot of ground in one test, web, mobile apps, native and hybrid mobile web, even APIs.
Wow, okay, that's broad coverage. Cross-platform, cross-browser, too.
Yep, mention that too. Almost essential these days.
How true.
And they make some bold claims about speed and maintenance, like 15 times faster test creation than something like Selenium.
15 times?
Yeah.
That's significant.
And potentially reducing test maintenance by up to 99.5%, which, as you know, maintenance can be a huge time sink.
Oh, tell me about it. That's often where automation efforts bog down. What about security and integration?
They mention SOC2 Type 2 compliance, which is important for security, and integrations with CI/CD pipelines.
Ah, so it fits into automated build and deployment processes.
Right, and test case management tools. Seems designed to slot into existing workflows.
And performance. Can it handle large test suites?
They claim it can run thousands of tests and get results back in under 30 minutes. So, sounds scalable.
Impressive.
And one more thing, it can apparently test things beyond the UI, like checking emails, SMS messages, even downloaded files like PDFs or spreadsheets.
Okay, that is comprehensive. It really covers many different interaction points in a full journey. So let's shift gears slightly. How do you actually design these tests effectively? Is there a framework?
Yes. The article suggests a kind of three-part framework. First part is build user functions.
User functions, what does that entail?
Basically, identifying the key features or actions within the system and how they connect. Then listing out, for each function, what data goes in, what actions are performed, and what data should come out.
Okay.
And also figuring out how these functions relate. Are they reusable, independent, that sort of thing.
Gotcha. The article had that banking example, right? Log in, check balance, transfer money, including to another bank, which means hitting external system.
Exactly. Check the new balance, log out. A clear sequence of functions.
Right. So that's step one. What's next?
Step 2 is build conditions based on user function.
Conditions, like variations or edge cases.
Precisely. For each user function, you define a set of conditions to test. Think about sequence, timing, different data inputs.
So for the login function in the bank example.
Conditions might be invalid password, valid login, maybe password complexity rules, checking error messages.
Makes sense. And for the transfer?
Maybe checking the balance after a delay for cross-bank transfers, testing what happens with insufficient funds, making sure the right error shows up.
Right, covering all the angles for that function. Okay, and the third part of the framework?
Build a test scenario. This is where you string together those user functions into a meaningful end-to-end flow.
Like the entire bank transfer process we just walked through.
Exactly.
Yeah.
You define that whole scenario.
And the final piece.
Build multiple test cases. For each scenario, you create one or more specific test cases. The article even suggests maybe having a separate test case for every single condition you identified earlier.
Ah, okay. So one main happy path test case for the successful bank transfer, then separate cases testing the insufficient funds condition, the invalid recipient condition, etc.
That's the idea. Really thorough coverage of the scenario.
Okay, that framework makes sense. Now, how do you measure if all this testing is actually, working well and providing value? Are there metrics?
Yes, definitely. The article lists a few common ones. First, test case preparation status. Basically, how far along are you in writing the tests you plan to write?
Simple progress tracking.
Okay. Then, weekly test progress. Looking week by week, how many tests ran, how many passed, failed, or weren't executed yet, compared to your plan.
Gives you a view of execution velocity and stability.
Right. Also, defect status and details. Tracking bugs, how many are open versus closed, what's their severity and priority, helps understand quality trends.
See where the critical problems are cropping up.
And lastly, they mention environment availability. How much of the scheduled time was the test environment actually up and usable?
Ah, yeah. Can't test if the environment is down. That can be a major blocker.
Exactly. These metrics give you visibility into the whole process.
Very practical. Okay, one last important point to clarify. End-to-end testing versus system testing. They sound kind of similar. How are they different?
Good question. Easy to confuse them. The article has a neat comparison. The biggest difference is scope.
Scope?
Yeah. End-to-end validates the whole system plus all those interconnected external subsystems. System testing focuses mainly on the software system itself against its requirements.
Okay, so end-to-end is wider, broader view.
Much broader. And the focus differs too. End-to-end looks at the complete process flow, like a user journey. System testing is more about verifying specific functions and features within the system.
Got it. What else?
The elements considered. End-to-end explicitly includes all those interfaces and back-end systems. System testing is more about functional and non-functional aspects of the system itself.
Right. And when do you do them?
Timing. End-to-end usually comes after system testing is done. You want the core system to be reasonably stable first. System testing comes after integration testing.
That makes sense. Build up the confidence level step by step.
Yeah.
Anything else?
One more. Automation preference. The article notes end-to-end often involves more manual testing.
Why is that?
Just the complexity of automating interactions across lots of different, potentially external systems. It can be technically tricky. System testing, being more self-contained, often lends itself better to automation.
Practical challenges of automating everything. Good point.
It is.
Okay, so pulling this all together, what's the main takeaway message about end-to-end testing?
I think the article really nails it. It's about verifying the software system and its collaborating subsystems work together correctly. And the biggest challenge...
Let me guess. Understanding that whole complex web of connections.
Exactly. Having enough knowledge of the entire system and all its interconnected parts. That's tough.
It really sounds like orchestrating a major operation, needing visibility into every single part and how they interact.
That's a good way to put it.
So we've covered a lot today in this deep dive. What end-to-end testing is, why it's so essential for complex systems, the process involved, designing test cases, metrics, and how it differs from system testing.
Hopefully it gives you, our listeners, a clearer picture of this really vital practice in making sure software actually works reliably.
Definitely. And now, something to chew on. Think about your own daily life online. You, as a regular user, probably without deep technical knowledge. Where might you actually feel the effects of poor or missing end-to-end testing? What little glitch, what small frustration might actually hint at a bigger problem with how different systems are talking to each other behind the scenes? Maybe something to ponder next time an app or website accesses.
CTSS Academy.